In this video, we're going to look at interrogating or evaluating association claims. So we're going to be looking at construct validity. We're, as always, going to be thinking, how well were each of the variables measured? Do the measures have good reliability? Is it measuring what it's supposed to measure? And what is the evidence for its face validity, its concurrent validity, discriminant and convergent validities? So absolutely everything that we talked about, I believe, in chapter 3. We're also going to be thinking about statistical validity, and we're going to ask 6 different questions. So, how strong is a relationship? We're going to be looking for the effect size. And, the effect size is describing the strength of the association. And you should be looking here and getting a picture of which of these associations you would find more compelling. Which one would you, excitedly call your mom about and say, oh, this is what I found, right? And I think this is the one that you would want to be calling about. We want to be thinking about which is a more important effect and why. So, generally, the stronger the correlation is, the better the effect. So we're probably going to be more likely to call home for this correlation than for this one. So just because it's a relatively small effect doesn't mean that it's not important. So in some contexts, tiny changes can be very meaningful. So for example, a swimmer who increases his or her speed by milliseconds can win or lose a race. And those effect sizes, when multiplied across many observations, can be really important. For example, with global warming or baseball, or agreeableness and popularity, that what happens in one situation may not matter as much as across situations. Now, as we're evaluating the magnitude of an effect, we're thinking about how large it is. So assuming it's based on a large sample, 1,500 data points, a 0.05 is very small, 0.1 is small, 0.2 moderate, 0.3 fairly positive or powerful, and 0.4 or negative 0.4 unusually large. So think about this. What size is this? How would you describe it? Or this one? How would you describe this correlation? Assuming each of these is the same size. Or this one, which is a correlation of 0.28. So the first one, a pretty large one for psychology. Second one, very small, very weak. I'm sorry, the first one. And the second one, this one is very strong. This one is very weak. And this one is probably moderate or fairly powerful. And notice that it doesn't matter about the direction. So I said that this was pretty powerful, despite it being a negative correlation. Our second question, how precise is the estimate? And that's, we're going to be thinking in terms of sample size and the precision of our accuracy and the size of our confidence intervals. Generally, when our confidence interval does not include 0, then we're saying it is significant. So as in this case. On the other hand, here we're seeing a confidence interval that is very large or relatively large, but again, doesn't include 0. So we would be likely to say, conclude that it's statistically significant. On the other hand, this is a precise estimate, small confidence interval, but it includes 0. So not significant. Third, we're going to be thinking about replication. So we're thinking, does it happen more than once? So in this case, we're seeing a correlation of about 0.3. And in general, that's about what we're seeing across a series of 5 studies. Now, there is one here, study 2B, where that isn't the case. And we'd want to know something about what's happening in this particular study that we're not seeing a positive correlation. And these are all on eavesdropping on happiness, back to Meal's research. So outliers could be affecting the association. If you look at these two figures, they are alike except for this point here. But notice the differences in those correlations. This one without the outlier is 0.26. This one with the outlier is 0.37, suggesting that this is a much stronger correlation. And if we remove some of these, some of these data points, as in here, so the proportion of outliers relative to the effect, we're seeing an even stronger correlation of 0.49. Here, we're seeing a correlation of 0.15. Few data points and no outliers. So one of the things that is happening here in this particular graph is we have a fair number of data points where things are pretty similar to each other. And yet the United States is very different from the rest. So we're seeing a much more unequal unequal society, and more of the household net wealth is owned by the top 10% of the population within that country. In this case, should the US be treated as an outlier? I think that's an important kind of question to ask and to be thinking about. Here, it's perhaps an even more important kind of question to be asking about. we're seeing a real cluster of data points here. And the United States, very different in terms of the number of guns per 100 people within the country and the number of gun homicides per 100,000. That here we might be thinking about the US as an outlier. And in this case, the correlation would certainly be much bigger, having the US included, than if we were only looking at the correlation here. Identifying the US as an outlier may have some policy implications then. So it may then mean that the World Health Organization, for example, might conclude that, that guns have, the number of guns in a country has very little relationship to the number of homicides in the country. As we're thinking about an outlier, partly what we're thinking about is whether or not our theory is wrong, and the presence of outliers may suggest that there is, some sort of problem with our theory. We're also going to be thinking about our fifth question out of 6 is there restriction of range? So here we're looking at SAT scores and college grades, correlation of 0.33. Okay, I mean, that's a moderate correlation, but not a huge one. Again, both of the right sides of this correlation are the same, but you notice that we have some more low scores to the left of the dotted line in the bottom case. And our correlation in this case is 0.57. And our question should be, who is it that we want to generalize to, I think? If we are only interested in using SATs to predict success at a fairly exclusive school where we have SATs above 1,200, then maybe our SATs aren't all that important. But if our school gets a very diverse set of applications, then it looks here like SATs does predict success and does predict it remarkably well. Our last question is there some sort of association, or is our association curvilinear? And here, if we're looking at our correlation coefficient, it's negative 0.01. Zero correlation, basically. And yet, if you look at the picture, it looks like there's a real relationship, right? In terms of, between age and years and use of healthcare system. That's because we actually have 2 different things happening at the same time here. The children tend to use the healthcare system a lot when they're very young. And by the time they're young adults, tend not to use it very much, but then use it a fair amount by the time that they are elderly and approaching death. And so as we are interrogating our associations or our correlation, we want to be asking a whole series of different questions. Is this correlation, or are our measures good? Do we have construct validity? Is our correlation impacted by any of a number of other kinds of factors that artificially either depress our correlation or increase our correlation? So mapping out your data is almost always a good thing. Pay attention to the figures. Take care, and I'll see you in our next video where we're going to be talking about internal validity in association claims. Bye-bye.